In this video, we're going to discuss about flag registers in 8085. So what are flags? We know that we perform arithmetic and logical operations in 8085. With every arithmetic or logical operations, these flag register denote the status of the result of a particular operation in 8085. There are basically 5 types of flag in 8085, even though the flag register is of 8-bit. As you can see, in the 0th bit, we have carry flag. The first bit is unused. In the second bit, we have parity flag. The third bit is unused. In the fourth bit, we have auxiliary carry flag. The fifth bit is again unused. In the sixth and seventh, we have 0 and sign flag respectively. Now let's discuss how these flags are activated or how these flags are set or reset based on the result. Let's go to our sign flag here. Let's say we are subtracting two different numbers. The first number is 01H and the second number is 04H. Now if we subtract these two numbers, the result is definitely negative. Now what happens during this operation of subtraction is that once the result of subtraction is stored in the accumulator, the sign flag or the sign bit that we see is activated. So whenever there is a negative result in your arithmetic or logical operation, the sign bit is activated. Whenever there is a positive result, the bit is reset, basically meaning the bit value is 0. Moving on to the 0 flag, this 0 flag is set whenever your result is 0 or whenever the result of the accumulator is 0. Let's say we have 02H in our accumulator and we have 02H in our register B and we are doing subtraction operation. So this particular subtraction operation is going to subtract 02 from 02 and the result will be 0. Based on the subtraction operation result, the 0 flag is now set. So whenever any operation leads to a 0 value result, then 0 flag is set or else the 0 flag is reset. Now we move on to auxiliary carry. So we know that we always perform 8-bit operations in our data, which means there are a sum total of 8-bit values in our operation: first, second, third, fourth, fifth, sixth, seventh, and eighth. So let's say we're adding two different 8-bit values. So these 8-bit values are basically converted to binary, and then the operations are done in binary here. Whenever we do some operation and during that operation we have a carry going from 4th to 5th bit, then in that case the auxiliary carry flag is set. Again, microprocessor handles 8-bit data during arithmetic or logical operations. So with dividing those 8 bits into 2 equal halves of 4 bits, now whenever we do some operation and if that particular operation generates a carry going from the 4th to the 5th bit, then in that case auxiliary carry is set. For example, let me write down two values here. So this can be 1111, which will be equivalent to F, and this can be 0 1 1 0. So let's say 1 0 0 1 and I have 0 here. Okay, for example, now when we add these two, so 1 plus 0 is going to be 1 1. Okay, we'll change this value to 1 just so that the carry is generated and then you understand what I'm trying to talk about. So 1 plus 1 will be 0 and the carry will be generated as 1. Still the auxiliary carry is not set. The auxiliary carry is only checked once we go past this 4th bit. So in that case we get a 1 carry here. So 1 plus 1 is again 1 0. So we get a result 0 and then we get a carry 1 here. Now whenever we get a carry 1 in this particular scenario, then the auxiliary carry flag is set. Or else if we don't get a carry here, then the auxiliary carry flag is reset here. Okay, now we move on to the parity flag. So whenever we talk about parity flag, let's take a value, example value of 38H. Okay, Now, if we convert this into our binary number, so 3 is going to be 0011 and 8 is going to be 1000. Now, for parity flag, what we do is we count the occurrences of 1 in this particular scenario. So, how many ones are present? We can see that we have 3 ones, which means we have odd number of 1, right? So, whenever we have odd number of 1, then our parity flag is reset, or basically it is 0. But when we have even number of 1 or even parity, then in that particular case the parity flag is set here. Moving on to the carry flag. In case of carry flag, now let's continue this operation that we did here. In this operation, the auxiliary carry flag is already set. Now we again continue adding this. 1 plus 1 is 1 0 0. Again we have a carry. 1 plus 1 is 1 0 0. Again we have a carry. 1 plus 1 is 1 0 0. Again we have a carry, and 1 plus 1 is 1 0. Again 0. We have a carrier. So whenever we generate a carry going from the 8th bit to the 9th bit, or if our result overflows and does not fit within the 8-bit space and it tries to go to the 9th bit, then in that case the carry flag is set. So these are the 5 different flags that is going to denote the status of any arithmetic or logical operation that you do in your microprocessor using some code.